This is section 626. We're going to be graphing two variable inequalities. We're going to be graphing a system of two variable inequalities. Now, when we graphed a system of equations, we were looking at where the points intersected. So remember, you could have one equation here, you can have the other equation here, and your solution was where they intersected. But when we have a system of inequalities, what's going to happen is you're going to have a graph, and the graph is going to have some regions shaded, and then you're going to have another graph, and it's going to have another region shaded, and your solution is going to be where those regions intersected or where they overlapped. So let's look at a couple examples. So we have x plus y is less than or equal to 4, x minus y is greater than or equal to 2. So this is both going to be solid, right, when I graph it. So we need to go through and we need to graph these. Now, it might be an easy way in this method to find the intercepts. So for example, if I pretended, remember the x-intercept is an x value, but your y is 0. So what if I pretended that my y is 0? Well, that means x is 4. And so I can put a dot at 4. Likewise, I can find my y-intercept. Remember, your y-intercept, your x is 0. So if I pretended my x is 0, I get y is 4. Well, now that I found my two values, I can just connect them. But now I need to know where it shades. So again, we can pick a point. I could pick 0, 0. And if I plug in 0, 0, I get 0 plus 0 is less than or equal to 4. That's true. So that side is going to be shaded. So since this is the side that's true, that's the side that's going to be shaded. Now we do the same thing to the other graph. So finding the intercepts, again, would probably be easier. So if I pretend, y is 0, I get x is going to be 2. And then if I pretend my x is 0, divide by the negative, your y is going to be negative 2. You can connect them. Those are your 2 points. Test a value. I can pick 0, 0 again. In this instance, I get 0 is greater than or equal to 2. Well, that's false. Now, because that's false, so that means that this side, right, that side is false. That means that this side is by default true. And I know we really haven't looked at an example or too many examples of that case, but you can just test it. So in this instance, like what if I plugged in, 0, 3? And so you'd get 3 minus 0 is greater than or equal to 2. That's true. This happens to be on the side that's true. So then shade that side. Now, remember, your solution is where the regions intersect. And so those regions intersect here. And so you darken that further, and that's going to be your solution. Now, you can do the same thing when they aren't linear. So in this instance, I have a parabola, and then here I have an absolute value. So we can do the same exact thing when we go through and graph it. So they're both solid because it's equal to. And in this instance, for the parabola, my horizontal shift is going to be 4. And so there's my parabola, moved it over 4. If you need to pick some points, you can pick some points. That's okay. But there's the shape of my parabola. Now I have to shade. And then remember, am I going to shade on this side of the parabola or am I going to shade on the inside of the parabola? And so the way we do that is we test a point. The easiest always is 0, 0. So if I plug in 0, 0, I get 0 minus 4 squared. Is that less than or equal to 4? Negative 4 squared is 16. 16 is not less than 0, so therefore it's false. So because this side is false, I can assume this is now true, and so I can shade the side that's true. Now I can graph the other one. now I have a reflection here, so I know it's going to go down. And then I have a horizontal shift again at 4, and I have a vertical shift again at 3. So remember, horizontal shift 4, vertical shift 3. And so going to graph that, I moved it over 4, up 3, okay there, and it's going down. And now again, I could test a value. So if I wanted to try 0, 0 again, you just can't test it if it's on the line. And so because it's not on the line, I can test it again. So if I plug in 0, 0, I get -1 is greater than or equal to 0. That is going to be false. So that means that this side, that region, that's going to be false, which means this side by default is going to be true. And so shading that side, now the answer is where the regions intersect, and so they intersect there. So to conclude today's lesson, we went over graphing a system of inequalities, and you just graph the graphs like normal. You test points to be able to see where it shades. Your solution is where they intersect, those regions that you shade where they intersect. This does conclude our lesson. If you have any other questions, please leave them in the comments.